Most developers don't struggle because they can't code. They struggle because they start projects the wrong way. They open Android Studio, create a project, install random libraries, restructure things 5 times or even more before they even build their first feature. The architecture is already breaking. So today we change that, because today we are going to be building, we're going to begin building our UI together. And it's not a demo project, nor is the toy app. Aurora UI is a toolkit that is built using Compose Multiplatform and designed to scale across Android, iOS, web, and desktop. In this series, I'm going to show you how real engineers structure applications that are meant to grow. By the way, if this is your first time here, I'm Mugumi Ali, a Kotlin-focused mobile and multi-platform engineer passionate about building scalable systems. And on this channel, we don't just watch tutorials, we build real software. As you can see, this is what we are going to be building. So this is part of what we are going to be learning together as we move on. And as you can see, it has different cards, it has different widgets. So we are going to be building this, and they are scalable. And you can see this is Android, this is desktop. When you click here, it moves to another screen, and then even here we can be able to navigate to a different screen. And we shall move on. We can toggle the dark theme, and also that also works the same way in the Android. And you can also see the different charts and everything. So we shall be able to create this together in this series, and we shall see how we can handle adaptability on different screens. So before we dive into the project, let's align on something very important. I would like to pose a question. What is Compose Multiplatform? Compose Multiplatform, often called CMP, is a modern UI framework that allows us to build user interfaces once using Kotlin and run them across multiple platforms. As you can see, this is one of the repos for Compose Multiplatform, and you can find everything that you will need to dive more into the framework. And now this means that instead of building Swift UI for iOS, XML or Compose for Android, React for web, you write your UI in Kotlin and then share it. Think of it like designing a house once, but being able to place that exact house in multiple cities without redesigning it. Now, this is where it comes in now, like another question. What if we don't have multi-platform? Now, what if we are using the native way? Now, that means if you're using the native way, that means you'll have separate teams, separate code bases, and then that would later lead to doubling up, maybe maintenance, having to have shared logics, and every time having to update multiple systems when you're shipping, even if it is to be one feature like this. Now I had to create a template that is production ready, and this removes a painful setup so we can focus on what actually matters, building great software. So now this template involves a clean architecture, it involves an MVVM pattern, it involves dependencies for serialization, call, components, among others, as we shall be seeing. Now what we shall do next is we are going to come to our desktop, then we shall create an empty folder. You can name it whatever name that suits you. Then mine, I've just called it Aurora V1. Open this folder, then I will have to copy this path. After copying the path, I'll place Windows R, and I place in CMD. I put C to change the directory, hit enter, then I put git clone the other template of ours. Then we shall be able to come back here, then we shall copy this link to the git repo that contains the template. We shall come back to here, then we shall paste, then we hit enter. Now what it is doing right now, it is trying to clone our project into the folder as you see in Aurora UI V1. And when it is successful, it's still receiving the objects. Okay, this one needs a little bit more patience. After the full objects have been received, so now we shall see the details being done. So if you're done cloning, you will just come here, then you will go to open. Then after going to open, you will click on this folder or new UI. Then after clicking it, you will load with the readme file open. Then you will wait for it to update the image. Usually it takes few seconds or minutes for the project to sync, so you just have to be patient. After the project is done syncing, this is how it will look like. So these are the Gradle scripts, and yeah, Gradle is just a build tool that helps you get all the logic and the code that you've written, and then compiles it to a useful application that you've been seeing. So when we expand the Compose app, we always have to switch to the project because it's the one which is pretty organized for Compose Multiplatform. So we can be able to see 4 source sets, and one of them is Android main. So here we just get to put all our Android specific logic inside here. And then we have the common main. Here, this is where we put all our shared logic, view models, among others, even the UI for Compose Multiplatform. So since we are using Compose Multiplatform, that means that everything that we are going to be sharing across all the different platforms that we're going to be dealing with, we shall have to put them here. And for now, I've configured the core, the data, and the presentation. So these are the clean. This is the clean architecture that we are going to be using, where the core, this literally contains the dependency injection folder. We have the platform, where we put platform agnostic functions, among others, like the expect functions. Then here we put the utilities. Here we can find the error handlers, the wrappers, among others. And then we have the data. So the data handles the models and everything. For example, formatting the user data. We have the repositories that will be handling. In real analogy, the repositories are used to handle data, maybe fetch them from an API or something, such that the UI or the view model doesn't have to fetch the data directly. But in our case, we're going to be using mock data. So we have the presentation where we find the theme, and we've already implemented the theme. As you will be seeing, we've already implemented the theme. And another thing is that we have the system UI. This is expect for making sure that Android you can be able to access features. For example, there are components for making the system bars visible, maybe in dark or light. Then we have the theme here, which has been configured with different colors for different color snippets that we already have. And we also have the typography. So this configures and standardizes the fonts that shall be used all over. For the maybe it can be for the themes, it can be for the text styles, among others. So we also have the UI, and under the UI we have components. So these components will be buttons, search bars, among others, that we can be able to use and share across the whole project. So we have the navigations, will contain the navigation components, among others. For example, the sidebars, maybe the bottom navigation views. We also have the screens. So I'll put all the screens which I'll be sharing. Then here we have the view model, which will be responsible for the state and communicating to the repository, and finally exposing the state to the UI. And we have the app. So this will act as our entry point, yeah, where we shall be able to run our app. We can extend this app to the JVM, the JS, and among others. So for the web main, in most cases it combines both the JS main and the WASM main. If there are features that can be shared between the JS main and the WASM JS main, this can be implemented via the web main, because this works via the web. We are now going to try to run our app and see if it can work on multiple platforms. Now for Android, you have to ensure that you already have an emulator. For this sake, I will try to put this emulator you're seeing here. Then it will try to load. After my emulator has loaded, I'll just click this green button to run it. So after the build, the Gradle build is done and the install is successful, you'll be able to see a new page on your emulator which says click me. You'll be able, when you click, you'll be able to see a beautiful logo which says Compose Hello Android 32. And yeah, so that means that we've successfully run it on Android, and so we have to also test for desktop as well. Run the desktop target, we shall just come here, we see the Compose app, and we shall have options of the JS, JVM, and the WASM. Then we shall just click on this to run the desktop target. Once the desktop is running, when you click the click me button, it should be able to display that logo, meaning that the desktop is now running properly. And when we also try running the WASM, the WebAssembly, it will also run properly. And as you can see, it is running on the web. When we click the button, we'll be able to show the Compose Multiplatform logo, meaning that it is successfully running on the web. And this successfully ends our first episode of building a responsive UI with Compose Multiplatform. And the next thing we are going to do, we are going to try, we are going to be doing the bottom navigation bar and also coming out with the side nav bar in Compose Multiplatform. So stay with us and with me to keep on going with this Compose Multiplatform series.